Okay, how you doing? I had a request come in about a type of problem here that I want to talk about. So it says an open box is formed by cutting squares with side lengths of 2 inches from each corner of a square piece of paper. What is the side length of the original paper if the box has a volume of 128 cubic inches? Draw a pic of the paper and or box. Write a quadratic equation to solve for the side length of the original sheet of paper. So what this problem is essentially asking me is it's asking me for a length of an original piece of paper that is a square. So the first thing that I'm going to do when I start to draw these things and I start thinking about these problems is I'm going to draw what it is they want me to find. And what they want me to find is, if I have a piece of paper, so let's draw this piece of paper that's a square. Okay, so there's my square piece of paper. It's not the greatest, but it was to know what's the length of these sides. Well, as it is right now, I don't know the lengths of those sides. So what I'm going to do is I'm going to label those sides with a variable. And the variable that I'm going to choose uses an x. So I'm going to say, okay, I don't know that side, but that's what I need to calculate. And if this side's x, well, since it's a box, then this side's x. So the way we go about this problem then from here is that now we start to use the directions to figure out what it is that I'm doing this, how am I manipulating my original box to create this information in the problem. So here we go. The next thing that it does here is it says, okay, you come up to this piece of paper and you start cutting squares with side length of 2 inches from each corner. So I'm going to cut squares of a 2 by 2 in each corner. So my next label draw that I'm going to do is I'm going to come up here and I'm going to go like this. So I'm going to draw it a little bit bigger. Sorry, it's not that great of a square, but I'm going to label this as these are my corners that I'm cutting out. And each one of these corners are a 2 by 2. So a 2, 2, 2, 2, 2, 2, 2, 2. So I labeled that. Now, the important thing is that if I cut 2 inches away from here and 2 inches away from here, I have this new length right in here. And I want to know, what is this new length going to be? So I want to essentially know, what is this new length right there? Well, I'm going to base that off of this information over here. And what I've labeled is that this total length side must be x. So therefore, when I come over here, what I'm doing to x is I'm taking away 2 inches and I'm taking away another 2 inches. So essentially what I'm doing is that this length is saying, well, that length is just x minus 4. Okay? And what I find out here is that if I come down here and I do the same thing, it's x minus 4. And right here, this is also that x minus 4. And then up here, I also have that x minus 4. So from here, if I take these boxes out, because remember I'm cutting them away, my new picture looks like this. So what I now have is this new picture that looks like this, where I know that this length right here is x minus 4. I know that this is a 2, and I know that all the other ones that correspond with the same thing are the same lengths. So the last thing that I'm going to do is I'm going to draw in my three-dimensional box, because now essentially I can take this and what it's saying is if I fold it up, I will then create a box. So here we go. So let's make that box. So here's my three-dimensional box. So folding up those pieces of paper, okay, what I have here is that if I fold this up, that this 2 then becomes my new height. So this length right here is my 2, okay? So when I fold them up to meet, right, so this length right here is right here, and this x minus 4 is this length right here. So the top of this here is x minus 4, okay? And then again, this, I kind of like twist it and turn it, but this is an x minus 4, so this is also an x minus 4. Okay? So what I have from there then is now I have everything that I'm going to be able to use to set up my quadratic equation to help me solve for the original. So I'm going to erase this, but the important part is notice how I drew out step by step by step. I did each thing, and what I started with was the original thing that I'm trying to find, which is this square that is x by x. So if I continue on from here, this is now what I'm going to use to help me calculate my volume. So I'm going to get rid of this stuff here, and I'm just going to start to use that over there. So what I now know is I know volume. The equation for volume is length times width times height. And I'm just going to plug all my stuff in. Well, volume we know is 128. We know the length is x minus 4, so that quantity of x minus 4, times the width, which we know is also x minus 4. and then I'm just going to multiply that by the height. So from here, this essentially now just becomes a solve this quadratic equation. And how do I know it's going to be quadratic? Because when I go ahead and simplify this, it's going to give me an x squared, which then makes it quadratic. So let's go ahead and just keep on going through. Well, a couple steps you can do. You're multiplying by a constant here, so I can divide this entire equation by that constant of 2. I can divide this by 2. And what I'm left with is that 64 equals, okay, this x minus 4, essentially x minus 4 squared. So I'm going to write it like this, and then I'm going to utilize a formula that I know. So essentially, again, I get this information from here, and I'm plugging it in over here. But the important thing to remember is going step by step by step to get to this. And then I'm just using length times width times height, plugging it in. Essentially what I have here is I already have my quadratic equation. So the original quadratic equation, so draw a picture, I did that along the way. Write a quadratic equation to solve for the side length. Here's the quadratic equation that I have, and now I'm just going to go through and solve this for x. Remember when you solve a quadratic that you must always set it equivalent to 0. So that's why I'm starting to do this, divide by 2. So at this point what I'm going to do is subtract 64 from both sides. And what I have here, let me write this up here. So what I now get is that I have x minus 4, the quantity squared, minus 64 is now going to be equivalent to 0, because if I subtract 64 from here, that creates that 0. And I subtract 64 from this side. So now all I'm going to do is go through, simplify this, factor it, get my factor pairs, find out what it equals. So here we go. So x minus 4, the quantity squared. There's a shortcut to this. You square the first term. So when we square the first term, we get x squared. Multiply those two together, and then multiply it by 2. So we multiply them together, it's negative 4. Negative 4x times 2 is negative 8x. So we get this negative 8x. And then we square the last term, which is a positive 16. And don't forget I have this minus 64 on the end, equals 0. So I'm left with x squared minus 8x. Positive 16, negative 64 is negative 48, equals 0. And then what I now come up to here is that I factor this new quadratic. So when I factor it, I end up getting the factor pairs of x minus 12 and x plus 4 equals 0. And at this point, you know that x minus 12 has to equal 0, so therefore x must be equal to 12, or I could say x could be equal to negative 4. Now, this x equals negative 4 is not it's called an extraneous root. Why? Because we're talking about finding a length, and you can't say a length is negative, so this is what we call an extraneous root, which doesn't make sense to the problem. So what I have here is that the original length of my side of my box was x equals 12. And if we wanted to check that, remember that x minus 4 was the side, and it had to equal the length times the width times the height had to equal 128. Well, the length times the width was x minus 4, both of those. Well, x minus 4 and x minus 4, so 12 minus 4 is 8. This one's also 8. 8 times 8 is 64. Times that by 2, you get 128. And there you go, and you have it. So the original length of the side of the box is a length of 12 inches. So I hope that helps for what you were asking for. I hope I explained it in a manner that you understand. If not, let me know. All right, thank you.